Okay, we're going to take a look into the 64 tetrahedron grid here. Getting a few insights based on things that Tom Kirsting has brought to light in his conversation with Eric Drake on Marshall Lefferts' Cosmometry site, and hopefully also throwing in a couple of extra insights as well. But let's see how we get on. The idea really is to just take a look at how the 64 tetrahedron setup works with PSUs and how they all come together to interface and form the flower of life pattern in 3D. So, you'll have to excuse me if I'm not too lucid, because I'm just making this up as I go along, but hopefully it will be fairly clear to see with this 3D graphic setup some of the ideas that are maybe a bit more difficult when just reading them as text. So, let's see what we've got here. We've got the 64 tetrahedron grid here. I've divided it into up-facing tetrahedrons and down-facing tetrahedrons. So we've got these up-facing tetrahedrons in orange, kind of orange colour here, and we've got down-facing ones in green, and these lock together, 32 of each of them of course, to make this 64 tetrahedron grid. Now the idea in terms of the PSU is that the PSU is a sphere that circumscribes each tetrahedron exactly, so we could switch on PSUs for all the tetrahedrons here, and you can see that how that starts to come together. So of course the tetrahedrons don't overlap, but once you circumscribe a tetrahedron with a sphere, all of the spheres will start overlapping and creating interesting patterns. Let's just take a look at that. And the pattern really depends on which angle you look at the grid. There's a blue one in there, that's one we're going to focus on soon. That may pop up now and then with the graphics, but just for the moment we can see if we look at this at one aspect we get a kind of cubic shape, which is something that Tom was kind of pointing out. And if we look at it from another aspect, the one that we more commonly sort of see depicted, we start to get this flower of life pattern coming out. It's maybe not too clear here. If I just swap out and look at a flattened orthographic view, you can see that more clearly. It is interesting to note though that once we start looking at this in 3D, we do get an overlap with the flower of life, the classic pattern, which I've got an example of here. The way it's drawn as a 2D representation, of course, we have a point in the centre of each flower where the lines meet exactly. This we don't really see when we try and flatten out the 3D version. You'll see as we go on that there is an equivalent 3D point, but when we try and look at the 3D version in 2D we get this overlap, which is part of the interesting way that it comes together. So let's move on then. So we can pick on this one PSU, the one I've actually got in blue, hidden in the middle there, and we'll use that as an example to work with to see how all of the PSUs will interact with each other in this pattern. So this PSU, let's just turn on the, so we can see, there's the tetrahedron that it circumscribes. So let's see, by circumscribing it, each vertex of the tetrahedron will be incident with the face of the spherical PSU. So from certain angles it will look like it isn't touching the edge, but of course in 3D you'll find an angle where you can see that point connect so don't get misled by that. That sphere is circumscribing that tetrahedron. Now, the way that Tom was looking at this, which is actually a very nice way of making things a bit more clear and a bit easier to imagine once you can really visualize it, is the way we can actually redefine the tetrahedron inside the sphere as a cube. And another way of looking at that, which is maybe more familiar, is to think about it as a star tetrahedron. If I just have a quick go at making a copy of this tetrahedron and then rotate it around. Like that. That's better. We can get ourselves a star tetrahedron, and of course you can see that maybe a bit more clearly is why we're getting the necessity for this sphere to be seemingly a bit bigger than the tetrahedron. But all of those points on both of those tetrahedrons and the star tetrahedron will be tangent to that sphere. So let's just turn on the idea of a cube, or a major cube as Tom was calling it, and we can see of course that a star tetrahedron does share the vertex points of the cube. That's part of its definition. So you can see that cube sitting around the star tetrahedron. We'll get rid of our second piece, and we can actually just think about this space the tetrahedron occupies as a cube. And once we do that, it becomes a bit easier to work out how the other PSUs interact with our central PSU. Let's just take a look at what would be the closest set of tetrahedrons to this central tetrahedron. That would be this 6 from within the matrix, these that actually share an edge with our central tetrahedron. And there will of course all be tetrahedrons facing in the opposite direction, the way that the grid locks together. So we've got these 6 down-facing tetrahedrons that share the 6 edges of our central up-facing tetrahedron. And we can look at the cubes that they would be defined within. And we start to see this kind of pattern emerging. Now, of course, a cube has 6 faces. We have 6 edges on a tetrahedron. They correspond to the 6 faces of the cube. So these 6 tetrahedrons will be the ones that are closest to our central one, as close as you can get in this pattern. And let's take a look at how that looks with PSUs. If we turn on our PSUs for those 6, this is what we would see. So we can call these our facing PSUs. Let's just turn up our tetrahedrons. We can see it a bit more clearly. And then to actually see the interaction, let's just turn off our boxes for now. Oops. And we can see that if I select our central PSU, you can see the highlighting I get here, and just select one of these facing PSUs. You can see there's quite a deep intersection between the two of them, how they cross over, and of course each of these 6 is in exactly the same relationship to the central one, so each will have a similar intersection being created by that relationship. Okay, so let's move out a step. We'll come back to these intersections in a second. So there will be other tetrahedrons that will also be in a position so that their PSUs would intersect this central one. And if we go back to our box analogy, and let's have a look at the tetrahedrons. That would be the next set. And you can maybe just see here, we've got this pattern of the 12 around 1. And these are the tetrahedrons in the same aspect as the central one, up-facing tetrahedrons. So we've got 6 from this way we're looking at it here, 6 in a ring around the centre, 3 at the bottom and 3 at the top. And these all share a vertex point. Remember the down-facing tetrahedrons we just looked at shared edges, these share vertex points. And if we go to our cube analogy, which can again help maybe make that a little clearer, we can turn on the cubes for these particular ones. And we get this kind of pattern around the centre. I think I'll just turn the tetrahedron off. Makes it a bit easier to see. So you can see how there are actually these 12 boxes forming this pattern around the central box. And they're a little bit further away than our facing PSUs. If we look at the PSUs, these are effectively, let's just drop back a step. Yeah, it's interesting just to note in terms of seeing how this fits together. Of course, each of these boxes, if I select our central box, each of these boxes is actually sharing an edge, whereas our 6 facing boxes were against the faces. You can see the gap there, of course, where the facing box would be. These 12 boxes are the ones that actually share one of the 12 edges of the central box in this way of looking at the setup. And that's really what's going on there. Let's take a look at how these actually intersect then. If we put our PSUs on, and let's just switch these boxes off so we can see a bit more clearly. And again, if I just get hold of our central one and just pick one of these edges, again you can see a similar kind of intersection, though smaller than the intersection we saw on the faces. And again, because each of these PSUs is in the same aspect as each of the others, you'll have a similar size and shaped intersection at a different point on the central PSU for each one. Okay, now there are also, just to complete this part of this idea of the cube, if we go back to our central cube, we've looked at the 6 faces and we've looked at the 12 edges of the cube. There are also the 8 corners or vertexes of the cube. These will also be touching against elements, and these are the tetrahedrons that are involved. Interestingly here, you can see that in terms of the tetrahedrons themselves, we've got 1, 2, 3, 4 that are actually touching on the vertexes, but there are 4 that seemingly have no interaction with that central tetrahedron. And this is all what this box analogy maybe makes clearer. When we look at them in terms of their bounding or surrounding boxes, we can then more clearly understand how the surrounding sphere will be relating to that central sphere. So let's just take a look at PSU spheres again. These 8 spheres will be sitting around our central one like this. Sorry, ignore that, press the wrong button. These 8, it's better. These 8 will be sitting around the central one like this. And you can see now they're tangent. Of course, it's, when you think about it, it's fairly clear that these two will be tangent because the vertexes of the tetrahedrons are going to be touching the edge of the sphere, so where they meet there'll be a perfect sort of tangency between the two. But the same applies for these other and seemingly more distant ones because of the cube. Well, not because of the cube, but the cube of course makes it clearer why that's going on. The centres of the tetrahedrons are exactly the same distance from the centre of this tetrahedron as are these that actually look to be closer. So let's just complete our look at how this box idea works then. Let's just go back to the box look. So here are our corners. You can see of course each one of the 8 hitting one of the 8 corners of that central cube. And we could, let's just turn you off that. We could turn all of our cubes on in this way of looking at it. So we've got our corners here. We could also look back at our edges and then at our faces. And you should see how these all lock together, of course, into what Tom was trying to illustrate with the idea of a Rubik cube. You can see clearly now that sort of analogy. We've got these 27 cubes, 26 around one, and these are all of the spaces that represent the tetrahedrons that of course define the position of the PSUs that will interact with any other PSU. You'll have this setup. Interesting also just to look maybe at the tetrahedrons that are involved there by themselves. If we turn them on, turn the cubes off, you can see this shape emerges out of it. We're going to get a truncated large up-facing tetrahedron and a down-facing tetrahedron, which isn't as obvious as the as looking at it in terms of that idea of the cubes, of course. But these are the tetrahedrons that define the PSUs that interact with that central one.